superior vena cava. Okay, there's something also known as inferior vena cava. Superior vena cava and inferior vena cava are pumping the blood from our body into the right atrium. Then from right atrium, it moves to the right ventricle through your tricuspid valves. Okay, from your tricuspid valves, the blood will move towards your pulmonary artery. Artery means the blood that moves away from the heart. Then it will go to your lungs, and from your lungs, it will get purified and it will come through your pulmonary veins into the left atrium. From your left atrium, it will move to your mitral valve, then into your left ventricle, which is the most muscular organ. Then the blood will be pumped out of your aorta throughout your body. Understood? This is the basic conduction of your heart. Yes or no?
Yes, ma'am.
Yes. Okay. Next comes your conduction done. Next, you have something which is known as conduction system of a heart. Can anyone tell me what is the conduction system of the heart? What is the conduction system of a heart? What is conduction, class? What is conduction? How your heart conduct electrical conductivity कैसे होती है हार्ट में?
Pump.
Sorry.
I don't know, ma'am.
Okay, so let me explain you this. Where is our beautiful heart? Okay, so this is the heart. Okay, animated photo of the heart. Next, draw. Okay, so look at this. This is the right atrium. Okay, so right atrium have. Okay, so look at in the right atrium, in the muscular layer of the right atrium, there is a certain cell which are known as your, actually whole your heart is made up of special tissue which is known as, what is known as myocardial tissue. Okay, and they have a specialized cell which is known as your AV node or SA node. What is this tissue known as over here? This is known as your SA. Very good. This is known as your SA node. What does SA node stand for? What does SA node stand for?
Sinoarterial nodes.
Sinoarterial node. What does it do? It will pump your blood to the. Okay, whenever it get activated, it will contract both your atrium and your both the atriums, right atrium as well as your left atrium. Okay, so it's like this. If you can imagine, this is your right atrium, and whenever this SA node get activated, it will contract the atrium. So once the atrium are getting contract, it is just pushing the blood out of atrium into the ventricle. So when SA node get activated, it will just contract both the atrium and the blood will move towards your ventricle. Now the SA node will, what SA node will do?
Relaxing.
Yeah, now it will relax. Now it will transfer the electrical conductivity into this area, which is known as
Right ventricle.
no, not right ventricle. It is between your atrium and between your ventricle, somewhere in the middle, which is known as your
AV nodes.
AV node. What AV node stand for?
Atrioventricle.
Very good. Now,
Ventricle
atrioventricle
node.
means both in between your atrium and your ventricle, there is a node which is known as atrioventricle node. Now, what is happening? First, your atrium are getting contracted with the help of SA nodes. Now, after atrium is, okay, this is like electric conductivity being generated. It will transfer the electric conductivity from your SA node to your AV nodes. And then when the electrical conductivity will move from your AV node into the bundle of Hayes and Purkinje's fiber. Okay, so this is the bundle of Hayes and these are the Purkinje's fiber, left bundle of Hayes, right bundle of Hayes, and then these are the Purkinje's fibers, small fibers. When the electrical conductivity is moving from AV node towards your Purkinje's fiber, it will contract the ventricles. So now what is happening? Look at this. Both are happening simultaneously. Right and left ventricle are contracting together. When the when the SA node is moving correct towards your AV node. So what is happening? Both the atrium are contracting. At that time, your ventricles are relaxing. Okay, so now SA node has conducted electrical to AV node. Now AV node is conducting its system, its electric conductivity to your ventricles. So now ventricles, when the AV node is conducting the electric conduction to your Purkinje fiber, at that time, your both the ventricles are contracting. So when both the ventricles are contracting, right ventricle will push the blood out of it through your pulmonary artery. Left ventricle will push the blood through your aorta into the body. So what is happening? Right ventricle and left ventricle are contracting together, and they're moving the blood out of its both the ventricle. At that time, your atrium is filling. That atrium is relaxing when atrium is filling. Okay. Understood? What is the electrical conductivity of your heart? Yes or no?
Yes, ma'am.
Everyone?
Yes, ma'am.
Yes. One more thing. Okay. One more thing, that what is this S1 and S2 sound is being generated? How this S1, S2 sound is generated? That is a lub and dub sound. How are they being generated? Can anyone tell me? Yes or no? Does anybody know how this electrical conductivity will start from your body? How do you produce S1 and S2 sound? Okay, so S1 sound is produced when these both the valves close. This is a mitral valve. This is a tricuspid valve, and this is the mitral valve. When they get close, there is a sound which is known as lub sound. That is a S1 sound, and S2 sound is generated when these semilunar valves or pulmonary valve or aortic valve closed. Okay. This is an important question. When does these valve get closed? When these mitral valve and tricuspid valves are getting closed. Does anybody know this?
No, ma'am.
When these valves, okay, just imagine this. When the atrium is getting contracted, what will happen? Atrium are contracting. So at that time, these valves are like door. So what happened? You are just trying to move from one place, one room to another room. So what will do? You will open the door, right? So similarly, when the blood is coming from your atrium towards your ventricle, it will open this valve. It will open this door, which is okay. So while opening, there will be no sound. But imagine this. When your right and left ventricle are contracting. So at that time, if you don't close this door, what will happen? The blood will backflow to atrium. This is what we don't want. Okay, we don't want the backflow of your blood from your right ventricle to your right atrium. That's why your body will close this valve. This will close your tricuspid valve. When this tricuspid valve will get closed when your ventricles are contracting. Okay, in order to prevent the backflow of blood. So when they will get closed, there will be a sound. That is a very strong sound. That is known as your S1 sound. Understood?
Yes, ma'am.
Yes, ma'am. Okay. So now what will happen? This right ventricle. Okay. Now what happened? When your right ventricle are contracting, these semilunar valves known as pulmonary valve and aortic valve get open, and blood will move out of this ventricle, right? But when right atrium are getting contracted, when right atrium is getting contracted, the blood is moving into your left ventricle, right? left ventricle and right ventricle both. So when your atriums are getting contracted, the blood are moving into the ventricle. At that time, you want these valves to be closed, because if you don't close this valve, the blood will move into the pulmonary and aorta. You want to hold it. Okay. So when these valves get closed, when your atrium is getting contracted, that they will produce something called S2 sound. Understood?
Yes.
Yes, ma'am. So this is how your S1, S2, and S3 sound are produced. S1. Okay, so whenever you see the sound, when you graph it, so it look like this. There's a strong sound and there's a phase of no sound. Then there will be a strong sound. Then there will be no sound. There will be a slight sound, which is, oh my God, I can make it very clearly. Just let me erase them. Okay, so, okay, let me just erase them. Okay, so what is happening? If you draw a graph, okay, if you draw a graph like this of the sound, so this is your S1 sound, there will be no sound for some time, then there will be S2 sound, and then there will be S3 sound, which is actually very abnormal. Okay, you should never have a S3 sound. It is produced when your extra blood is, okay, it is produced when your ventricles are contracting and still there is some blood is left, especially in the heart failure. If you see S3 sound, okay, S3, it also known as S3 gallop sound, it is created or it is heard when you have heart failure. Okay, when you have heart failure, at that time you will see. Okay, class. So are you all available here in the class? Can you understand why this S3 sound is being produced? Okay, it is produced because you have heart failure and there's excess of blood. So when this ventricle are getting closed, still there's some blood remain and they vibrate, and this is called S3 sound. Okay, so I make this on S1, okay, and then you will have S2, okay, then you will hear S3 sound, and there is one more abnormal sound which is known as S4 sound, which is actually produced before your S1 sound. Okay, this is very important. Everyone, make this thing in your notebook. It works like this. S1, then you have S2, then you have S3. Before S1, you have abnormal sound, which is known as S4 sound. This is not important in NCLEX, but they might ask you, when do you hear S1 sound? You hear S1 sound, sorry, S4 sound before S1. Okay, this is the strategy. S1, S2, S3. Before S1, you have something which is known as S4 sound. Understood?
Yes.
Everyone?
Yes, ma'am.
Okay. Let me erase this. And what more do I want to explain over here? Nothing more. Chalo. This is done. This is done. Right ventricle. Okay. Yes. I want to talk something about ejection fraction. What is ejection fraction? Does anybody know what is ejection fraction? Yes or no? What is ejection fraction? Have you ever heard of this term? Ejection fraction. What? Fraction. What is the spelling? Okay. What is ejection fraction, everyone? What is fraction? What is fraction?
Um,
Can anyone tell me?
मैम इजेक्शन कंट्रैक्शन जब होती है सिस्टोलिक फेलियर लीड्स टू कंट्रैक्शन इजेक्शन जब में ब्लड फिल होता है.
No, actually you're correct, but थोड़ा और इसको करो, sharpen करो, elaborate करो इसको. Okay, imagine in your left ventricle. Okay, imagine in your left ventricle you have 100 ml of blood. Okay, in your left ventricle you have 100 ml of blood. When your ventricle is getting contracted, okay, in your ventricle is getting contracted, only 30 ml blood was ejected. Got my point? During your ventricle filling phase, there was 100 ml. So when your atrium was getting contracted, at that time you had 100 ml of blood in your ventricle. But when your ventricle got contracted, the force was so low that only 30 ml ejected. So this is known as ejection fraction. Ejection fraction means how much the blood ejected from the ventricle, okay, in the value. So it's only 30 ml. Understood what ejection fraction is?
मैम एंड रेस्ट ऑफ 70% वो जो ब्लड वो वेंट्रिकल्स में रह जाता है.
Yes, because it's very important to understand ejection fraction is only it's very important in heart failure to diagnose the heart failure. Okay, and how much the blood, the ventricles are so weak that they cannot contract forcefully, leading to the retention of volume of blood in your body. And your body is not, sorry, the retention of blood in your ventricles. So remaining 70% your blood is in your ventricle.
Okay.
This is known as ejection fraction. Understood?
So, ma'am,
Yes.
so we're gonna get a QRS by ventricle, right? So it's gonna be down as well.
Obviously, it will affect. Okay, some good question. Let me explain you about QRS also now. Okay. Insert new slide. Okay. How can I change the slide color to blank? Obviously, I want blank. Okay, chalo. So let's understand this with, okay. Let me make this a heart for you all. Okay. So this is the heart. From your SA node, you have AV node, then you have bundle of his, and then you have Purkinje's fiber. This is how it's working. Okay. So when your SA node conduct electric current to your AV node, you have okay. So what happened whenever your, okay, simple physics is there. So whenever the electron will move from a direction, okay, from your positive to negative, something like this, they will produce an electric conduction. So you can, from your galvanometer, you can see that there is a flow of electron, which will show on electric paper. If you will see, okay, whenever you put your patient on your ECG machine, what ECG is doing? What does ECG stand for?
Electrocardiogram.
Electrocardiography.
What does it mean? What does it mean? It means that your graphing means you are analyzing something. Your graphing means you're showing on a paper. Electrocardio, whatever electric current or whatever electric things are happening in the heart, you are just putting down on a paper. Electrocardiography, you are just graphing it down. So you will see that when your SA node is transferring current to AV node, there is a positive deflection, which is denoted by P wave. Okay, it is a P wave. So from positive to negative, it's a positive contact. Therefore, you will see a P wave. Next, from your SA node, the current is moving first down, then into your Purkinje's fiber, right? So you will see a deflection over here like this. A streak like this. Okay, why we have, oh my God, stop this. Okay. Okay. So from here, you will see a positive QRS complex, and then you have a T complex. So what is this? P wave, then you have something known as Q, R, and something known as your QRS and T. Okay. So what is this? PQRS. PQR denote your ventricle contraction. So when your current is moving from your SA node to your bundle of phase and Purkinje's fiber, it will form a graph. Okay, because some current are in the positive direction, some are in the opposite direction, that you have two values. QRS, PQRS will donate your ventricle contraction. And then you have something called a T wave. Why T wave is there? Because when your ventricle contract, okay, there is a deflection and you will see electric conductivity. T wave indicate ventricle relaxing. Imagine this, my hand, these are ventricles, okay? They are contracting and they're contracting like this, very fast, okay? But when they're relaxing and ventricles are so big, they are so big that when they relax, it will also produce a current, which is known as your T wave. So T wave indicate your ventricle
Ventricle relax.
relaxation. So P wave indicate
Con-
Ventricle
which
Ventricle.
contraction? It will denote your atrial contraction. So any problem related to atrium, I will able to see on my P wave. Any distortion in the P wave will indicate that there's something wrong with my atrium.
Atrium.
Understood? Yes or no?
Yes. Yes.
Any distortion, if I see on my P wave, it means that my ventricles, so my atriums are not working fine, right? Next comes your QRS. QRS complex will denote my ventricle contractions, like how well my ventricles are getting contracted. If I see that ventricles are PQRS are very wide, okay, it's like this. Where's my curve, right? So PQRX are like this. Now they're very wide, okay? Initially it was so short, okay? Now they are wide. Wide means they're taking a lot of time to contract. Okay, a good QRS complex is always less than 2.5 boxes. Less than small pipes. There is small boxes in ECG and a good vent. Okay, please mute yourself, class. Okay, mute yourself. QRS complex are very short. Okay, it has to be very short because you need to push the blood out of your ventricle. Okay, if it is okay, these are ventricle, okay, and they are contracting like this. Will it able to produce that force? They will not able to produce that force that is required to perfuse the blood to the tissue, right? They need to be very quick. I'm getting a So we were discussing about what we were discussing about. Okay. Yes. Okay. So understand this thing. If your QRS complex is wide, it means that the ventricles are taking too much of time to pull the blood out of its heart, and which will not produce enough force. When it will not produce enough force, it will not produce enough BP. When there's no enough BP in your blood, in your body, there will be no perfusion. There will be no perfusion. There will be no oxygen to your cells. If you don't have oxygen to your cell, your body will go into lactic acidosis, okay, because they will go into anaerobic respiration and slowly they will die. Understood?
Yes.
Especially your brain. If they die, if they don't get oxygen within 8 seconds, all the mitochondria, that is a powerhouse, they don't get oxygen. Okay, this is what happening in India right now. Okay, in India or in all the part of the world is getting bankrupt. Why not bankrupt? All the countries in the world, they are not working now. You know, there's a shortage of so much of electricity right now, shortage of gas, petrol. Okay, because that's a powerhouse, right? You need energy to work. You need energy to work. That is every country need a petrol, kerosene, all the diesel to work, and they're not working. Everything is shutting down. Okay, this is what actually happened with our heart. When heart will not provide energy that is from your blood, so it will your whole body will go into shutdown mode, especially your brain. Understood?
Yes.
Clearly, so this is what the function of ECG, PQRST, and T wave. Okay, let me tell you something more about T wave. Your T wave should not look like this. It should always look like these. Uh, it's like will take more time and then less time. So yes. So if I draw this side should not equal to this side. Okay, there has to be this will it look like this. Okay, this is a correct way of drawing T wave. Slightly sloped. Okay, it will more time, then it will contract. It relax like this. Relax and then relax. Okay, relax and then relax. Slowly and then quickly. So that's why your ventricle relaxes this way. That's why you will see the graph like this. Okay, understood everyone?
Yes, ma'am.
Okay, now we have what can you see on my screen?
ECG.
Okay, ECG. Okay, so now let me show you a real ECG, a real graph, and I will tell you will tell me where is P wave, where is Q, where is QRT. Okay, class, can you see this image in front of me? Yes or no?
Not yet, ma'am.
I
Yes,
think
ma'am.
you can now see this
Cannot.
scene. Okay, now let's
Yes,
see
now.
the stages. Okay. First, let me tell you something about how many lead can you see?
4.
4? No, no 4. Can't see.
So
1. Achha, okay. I'm not talking about lines. I'm not talking about rows or column. I'm not talking about rows. I'm talking about lead. Okay. See this. Can you see this 1, 2, 3, 4 right over here?
4. Mm-hmm.
Yes, okay.
16.
Can you see this 1, 2, 3, 4? This is 4, okay.
16. Yeah.
1. This is the whole ECG. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 you can see, right?
Yes.
Okay. AVR, AVL, A1, 2, 3, 4, 5. So what is this? Basically, this is lead 1, this is lead 2, this is lead. Where is my pen? Show you. Okay. See this. What happened? I'm just drawing it over here so you can clearly see. Whenever we put a patient on a lead, okay. So whenever this is the heart, okay, and all of you, I think everyone has or had did a ECG. Okay, everybody know how many leads do we put? So we put one lead over here, second lead over here, third in the leg, fourth in the right left. So this is the limb. Then you have chest leads. Okay, chest lead is 1, 2, 3, 4, 5, 6. So 6 leads on the chest and your 4 leads on your hands and your feet. Okay. So what is happening? Basically, one lead over here. I'm just imagine these are dot as your is your legs. Okay. Then one is over here. Okay. Then here's one over here. These are your legs. These are your legs and these are your hands. Okay. Next, you have something on your heart. 1. Then you have 2. I made it incorrect. Imagine this is a person. Okay. Imagine this is a person. Okay, so 1, 2, 3, 4, 5, 6. So this is how what happened. Basically, the current is moving from here. Okay. Next, this is a neutral. Okay, one leg you have a green lead, which is a neutral. Then a current is moving from here. Okay, and then one current is moving from here. Okay, so what's this doing? One current is moving from here and then to the legs and then to the upward. So this lead is lead number 1. This lead is lead number 2. This lead is lead number 3. Okay. This is how 1, 2, 3 leads are generated. Then you have AVR, AVL, and AVFL. What are these? These are your vector. You know what vector? Can anyone tell me vector from your physics? How many of you studied physics?
Velocity? No.
How many of you have studied physics in your 11th and 12th? No one? No one has studied physics? Just tell me honestly. No or yes?
No.
No, ma'am. Okay. So, okay, I will explain you. So, who said velocity?
Herman.
Herman,
iPhone 3.
you have studied physics, right?
Yeah, I study.
Yes, because I know. Whenever we hear this velocity, we understood that someone has. Okay, now understand what is your vector. Vector means anything has a direction is vector. For example, if I'm telling you that your current move from your negative to positive, so it is moving in one direction, that is negative to positive. This will have a vector. Whenever we give something direction, any current or vector quantity, okay, anything that have a direction is called vector. Anything which don't have a direction is called scalar quantity, basically. For example, distance. Okay, distance. For example, you have, if you want to move from A place to B place and you're moving like this. Okay, so this is your direction. But I'm telling you, if you have to move from A to B, the straightest is your displacement. So this is a vector quantity because it has a direction. Okay, next, because it is moving from positive to negative and from positive to negative, these three they are making a triangle, hence they can create a vector. Okay, one vector in this direction, another vector in this direction. So from these three directions, we create three more directions. Okay, this is just a complex physics. Don't get into this. But yes, AVR, AVL, and AVF. This V stand for vector. Vector to right, vector to left, and vector to front. Okay. So these are the vector which is being produced by these three current, and they see the heart in this direction. Okay. Now you have lead V1, V2, V3, V4, V5, and these are your chest lead. So whenever you see such kind of lead, you will able to understand that this is how your ECG is there. Okay, this is how 12 lead ECG. If you know what 12 lead is, 3, 3, 3, 3. What is this? 1, 2, 3, 3 plus 6 plus 7, 8, 9, 10, 11, 12. So this is a 12 lead ECG. And we have इसको rhythm ECG बोलते हैं because we have counted from the just to count the rhythm, you have a rhythm ECG. Okay, I hope something basic you have understood from this. Ki this lead 1, lead 2, 3 are the leads that we have put on the legs. Okay, V1, V2, V3, V4, V5, 6 are your chest lead, and these VR, VL, and VF are your vector lead. This is how ECG is there. So now, whenever you see that, okay, you have problem in this lead. Okay, have problem in this lead. So there will be problem in that means that something this lead has a problem, means this part of your heart has a problem. Okay, if you see any problem in lead 2, it means that this part of a heart has a problem. If you see lead 3, if there is abnormality in lead 3, you will see that this part of a heart has a problem. Okay, when you see lead AVR, it means then this part of a heart has a problem, means the downward part. And this is how, and your chest lead see the heart from straight, from like front. So whenever you have problem in V1, V2, V3, V4, it indicates that you have a problem in your front view of your heart. So this is how we map the heart into small quadrant. And whenever you have any problem in any lead, which directly indicate that problem in the ECG. Okay, so this was all about something basic to ECG. Okay, understood till now? Something Not all the thing you're not able to understand, I know, but any some idea about ECG? Yes or no?
Yes, ma'am.
Yes, ma'am. At least you should know basic about ECG. Now we will learn about how to calculate the heart rate. Now we have to tell you something about small boxes and large boxes. Can you see the small boxes? 1, 2, 3, 4, 5, 6, 7, 8. These are the large boxes. Okay. In the large boxes, you have 5 small boxes. Okay. In one large box, you have 5 small boxes. 1, 2, 3, 4, 5. Basically, they are the time. Okay. Denote your time. One small box is how many seconds? 0.02 seconds.
0.24.
0.2 second. Okay. So 0.2 into 5 is 0.10 second. So one big box is 0.10 second. Okay. Understood?
No,
Yes.
ma'am. Can you explain, please?
I'm telling you. This is 0.2, this is 0.2, this is 0.2, this is 0.2. No, not like this. Give me 1 second. Okay. Okay. Can you see my screen?
Yes, ma'am.
So this is small box, one small box. Where is this?
Is something. Yeah.
This is many. Okay. What is this?
Hmm.
What is this? How does it come?
Oh my.
Okay. Okay. Can you see this? Yes or no?
Yes,
Yes.
ma'am.
Okay. So this is a small box. Okay. So this whole small box is your 0.20 second. 1, 2, 3.
Yeah.
0.20 divided by 5. How much will get? I think 0.4. I think. Right? Yes. So
Yeah.
one small box, this one small box is 0.4, 0.4, 0.4, 0.4. So hence it will become 0.20 seconds. So if I say that from this, from your, this is the P wave. P wave means atrial contraction, QRS means your ventricle contraction, and T wave means your ventricle relaxation. So from
Relaxation. Yeah.
here to here, starting this, okay, this
Mhm.
point, how much second does it took? From where to here? Just calculate the seconds.
Ma'am, one small box is 0.2 second.
0.4, sorry, 0.4 second.
Point eight.
Let's calculate. This is
4.8.
0.20 second. This is 0.20 second. Okay, 0.20 plus 0.20. How much? Next you have 0.04, 0.04. That is 0.08.
0.08.
08. How much? 0.48 second.
Yeah.
So meaning one contraction is of 0.48 second. Imagine fraction of a second, like so quick. One contraction is less than 60 seconds. This is very less than 60 seconds. Come on. Very less than 60. So one contraction is of how much? Okay, check the normal contraction, how much it is took. One contraction seconds. Let me see. Okay. Okay. So it is somewhere around 0.2. 0.2 to 0.4 second. 0.2 to, oh my God, 0.2 to 0.4.
4.
तो ये कितना हुआ है? 0.48
4.8.
हुआ है, right? Around this much. So this is a normal contraction. Got it? Yes or no?
And 0.48 is normal.
Yeah, 0.48 is normal. Okay. If I'm writing 0.4 and I'm writing 0.40, both mean the same, right? Don't get confused. It's like 0.4 is not bigger than 0.40. Both are same. Got it? But yes, 0.04 is smaller than 0.4. So this is 48, this is 40, means the same. Approximate. 0.0 second, 0.8 second का अंतर है. That doesn't mean the same. That means the same. Chalo. Did you understood, all of you?
Yes.
Yes, okay. So one more thing, okay, we weren't able to take class for 2 days because I was not well. Okay, and tomorrow we won't be have any class, and rest of the information will be provided you by your admin. Okay.
Okay, ma'am. Okay.
Okay, class. Thank you so much. Please do the questions. We have completed our nursing foundations. Okay, we are starting with the cardiology.
Okay.
Okay, class. Take care. Have a good day.
You too, ma'am. Take care. Bye.